Hey everyone! So today we're going to talk about arrays. This is the continuation of the file I/O lecture as well. So these two topics go really well together. You can use them independently, of course, but you use arrays a lot when you use file I/O and vice versa. So we thought we'd kind of lump these together, but that's why they're in two separate videos. Okay, so what are arrays? We've kind of talked about arrays before without calling them that. When we use strings, we're actually using arrays. So arrays are when I have a bunch of data I want to lump all together and save it in the same place. So if you think about your computer's memory like a toolbox, it would be reserving a set of drawers all together to store a bunch of data that I want and not just having them be randomly pulled all over. Okay, so arrays we use to conveniently access groups of data, large groups of data. That's why we use it for strings, because we're going to have a group of characters together that always are going to go together in a certain order. Arrays are grouped by elements, so you can't, for example, have a char and an int in the same array. They all have to be the same data type. So I can have an array of ints, I can have an array of chars or floats, but I can't have them intermixed. If you have an array of chars, it's a string. We talked about this a little bit ahead of time, and we'll get more in depth on strings later on. The syntax, so the definition of an array looks like this. Type here is just data type. So this is going to be int, char, float, double, whatever you want to call it. The name of the array, naming convention is the same as variable names. And the size. So you've seen this before when we do char, and then the string name, and then the size of the string, which I usually tell you to do 80. But you can, right, have an array of int type. Call it my array or something, and have a size of 6. Right? I can make this any size I want. Remember when you're defining this that you do have to use square brackets, not curly brackets or anything else, but you should be used to this now when we've done strings. Okay, so why use an array? Right, here's a great example. I'm recording a 3-minute song. It takes 44,100 samples per second, and with recording each one of those as a 16-bit integer, if I had to record each one of those samples individually as an individual variable, I would end up with almost 8 million different samples for just one 3-minute song. That seems pretty impractical to have to define 8 million different variables. So instead, what we can do is we can declare an array, type int, call it samps, and make it this big, right? 7,938,000 total units inside that array. Each element of the array is in and of itself an integer. So I could have int samps 0, int samps 1, int samps 2, etc., etc. That number would go in these brackets, and that would just be the number element that I'm accessing. Now you'll notice I started at 0, right? Just like when we talked about strings, arrays always start at the number 0. So if I declared this 7,938,000 big, I'm actually going to start my array at 0, which means I would go up to my last element in the array would be 7,937,999. Okay, so hopefully that makes sense to you. Each one of those individual elements, which is what they're called in an array, can hold one integer. So we can hold one data point with each individual element. I talked a little bit just about this. The number inside those brackets is called the index number. If you're talking about the variable itself, it's called an element. But if you're talking about just the number inside the brackets, it's called an index number. Indices are always integers. Now, this probably makes sense to you. We can't have samps 2.5, for example. That just doesn't make sense. We can't access the 2.5 variable in memory, right? Doesn't make any sense. So these are always going to be integers, even if I have it storing floats or doubles or something. I talked about this too, but just to remind you, the first element 0, the last element is actually the total size minus 1, because we start at 0, so our biggest element will be 1 minus the maximum. One of the most common errors, and we'll come back to revisit this, is exceeding array size. So what happens here is you start to index an array. Let's say you've declared it 6 big. Well, what happens in memory when you start to say my array 7 or my array 8 and you've only declared it as 6 big? This will actually not give you an error message usually. It can very much mess up your program though. Okay, so we talked about this, but here's just the example written out. My first element in SAMPS is element 0, right? Or it's index 0, element number 0, and it's holding number 192. So that's the data point that's stored in SAMPS 0. SAMPS 1, 214, right? And I'll keep going, 2, 3, 4, etc. up until this. This is my very, very last sample. And I can store whatever integer I want in it, but it doesn't actually go up to 7,938,000 because I started at 0, so I subtract 1 from the max. So any C data type can be used for an array. We talked about that. Every single element in the array is of that data type. So if I have a char array, which is also called a string, all of those elements will be chars. Or if I have a double array, every single element will be a double. So here's some examples. I have integer, my array name is A, and it's 20 big. So that means it goes from 0 index to the 19th index, right? I go 0 to 19. If I have an array 99 big, it goes from 0 to 98, right? It's always one less than the maximum. Y5, this one's probably kind of easier to think about. I have Y0, Y1, Y2, Y3, and Y4, and that's a total of 5. So this number here in the index is giving you the total, but the individual indices will always start at 0, and the last one will be 1 minus the last. Anytime I declare an array, right, I'm declaring this array that's giving me A0, A1, A2, A3, etc. I can actually access any individual element I want whenever I want. So I could say A18, and it would show me what's there. Similarly, X2, Y1, Y3, I can set each of these equal individually as I want to. Okay, so the real point of arrays is so that we can store values sequentially in memory. I want to take a bunch of addresses and I don't want to have to access just randomly skipping around for each one of these data points that want to be grouped together. What I actually want to do is say, I'm going to take this whole segment, right, all of these memory slots all together, and I'm just going to store all my stuff sequentially in those so they can all be grouped together. Now you might think, well, Professor Casey, why would you want to do that if I can just go in and access it by name? Well, you can't always. What happens when I want to send arrays down to functions, for example, or I want to use them with files? When you're doing stuff like that, you have to access arrays through pointers. Because of this, and because this is so powerful a thing that we can store all of these numbers sequentially, all these data points sequentially, when you declare an array, it's actually automatically declared as a pointer. The pointer for the array points to the very first address in the array. That way, when you're counting through, you can just keep adding one memory slot to your array and access the next element in memory. Now, if we look at these, right, you can see I have an integer array here of x3, and I have a char array here, string 4. If you look at the addresses, I didn't make a mistake here. This one starts at 128. The second element, though, is at 132. This is an individual memory unit for an integer. So an integer takes up 4 bytes, if you remember, from the data types lecture. So it needs a full 4 bytes to be able to store just one number. If I had doubles, for example, if I was storing doubles, I'd need 8 bytes. So these would skip 8 every time. Now, if I'm working with a char, right, chars only need 1 byte of memory. So the first address will be at 181, and I can just count up by ones. So you have to know what data type and how big a memory slot it takes when you're starting to use pointers.